So in this video we're going to look at radian measure. This is a different way of maybe solving trig equations and things. Instead of using angles, we use what's called radians. And if any of you have ever put your calculator in the wrong mode, you'll hear your teacher say, make sure it's on degree mode. Your calculator can easily go into a thing called radian mode, and that's where this has come from. It's very difficult to explain, and there's lots of different wonderful videos on YouTube, etc., explaining it. But I'm going to try and show you the simplest way that I can make sense of it to explain to my class. Okay, so we all know that a circle is made up of 360 degrees. And to find the radius of a circle, we use the formula C equals pi d. So imagine, look at this picture I've got here. I've made a sector with two sides the same radius. Obviously there would be if it's a sector. Centre to the outside is always called a radius. But what we've done is we have drawn them that the circumference, this curved part here, is the same length as the radius. So my radius would be 2, that curved bit of the circumference would be 2 as well, or even 1. Now what happens is when you do this, if you were to do this on a circle, this angle in the middle here that we make is called 1 radian. Now if you were to keep doing this, you would do exactly 6.28 of these sectors into your circle. So you'd have a little one left here, so you'd have 6 full ones and 0.28 of another one. Does the number 6.283 look familiar at all? What about if you were to half it? If you halved it, you would get 3.14, which is equal to pi. So what actually happens if you have the full circle is worth 360 degrees, but this full circle can give us 6.28 radians, which is 2 pi. So 2 pi is the equivalent of 360 degrees. Therefore, that means that pi is the equivalent of 180 degrees. Okay, so that's the most important thing to take away from this. And then things like our sine and cosine graphs now are going to be measured. Instead of being like this and going from 0 to 360, they're going to go from 0 to 2 pi. And in the middle, 180 would just be pi. So what would that make 90? Halfway between 0 and pi, well, that would be pi over 2. And 270 would be 90 onto that pi, so it would be 3 pi over 2. But that'll get discussed more in a wee second. We are going to focus on converting between degrees and radians because you need to be able to do this really quickly. So when we teach you percentages in first or second year, we always teach you the core ones that you can get everything from, like your 10% and your 25%. The same is going to happen with radians. There's different ways to teach this, but I think if you can remember these core ones, then you can get all your other ones from them, because if we ever ask you to turn degrees to radians and so forth, it's always multiples of the same common numbers. So we already said that pi was 180. If I want to do 90 degrees, you should hopefully be able to say, well, 90 degrees is half of 180. So 90 degrees is half of pi, which you write as pi over 2, 180 divided by 2. 60 degrees, 3 lots of 60 go into 180, so that would be a third. So pi over 3. And in reverse, I've now given you in radians and I want it back into degrees. So to get this one, the pi over 4, really I'm asking you to do 180 divided by 4, which is, simplest way is half it and half again, but it's 45 degrees. And then this one here is 180 divided by 6, which is 30 degrees. So these are your core ones, because if you know 30 degrees, you can get 60, you can get 120, you can get 150, you can get 300 and so on. If you know 45 degrees, you can get 45, 135, 225, all these very common multiples of 45. So let's look at these in a wee bit more detail. So we're going to meet these 4 again. Okay, so what we've got here is we have some really common angles which we have to be able to convert into radians, all right? So the core ones I gave you on the previous slide are already in blue. So we knew 180 was pi, 360 is double that, so that's 2 pi. 90 was half of 180, so pi over 2. And 270 is this one times 3. So it's 3 lots of 90, which is 3 lots of pi over 2. Now we got all them without any working, just by knowing that pi was 180. Similarly even, we said that 30 was pi over 6 because 6 30s make 180. The connection here is to get 150, we're just doing 30 times 5. So your fraction will be 5 pi over 6. 210 is 30 times 7, so that would be 7 pi over 6. And 330 is 30 times 11, so that would be 11 pi over 6. So if you remember these core ones, we can get any multiple of 30. Similarly, here's 60, so we know the 60 is pi over 3, because 360 is going to 180. This one is just double of 60, so double the top number, so you get 2 pi over 3. 240 is 4 lots of 60, so times the top number before, we get 4 pi over 3. And then 300 is just 5 lots of 60, so we're timesing our 1 by 5, so you end up with 5 pi over 3. Then we've got 45 degrees. 4 of them make 180, so that's pi over 4. It's worth knowing your 45 multiples of 45, and I always remember them actually from this thing here. Now your compass. Every slot in there is 45 degrees, so 4 of them make 180, and then another one makes 225, and so on. So I remember my 45s from thinking of a compass. So 135 would be 3 lots of 45, so that would be 3 times pi over 4, so 3 pi over 4. And then 225 would be 45 onto your 180, so that would be 5 lots, so that would be 5 pi over 4. And then the last one that's always worth knowing is 72. 72 goes into 360 exactly 5 times. So 72 would be 2 pi, because that's 360 over 5. Okay, so 72 degrees is a fifth of a circle. So it's 2/5 of pi. Now, there's a wee summary of what I just did there. They were all degrees into radians. You could always use this simple rule here, which is you divide by 180 times by 5. So if you're really struggling, let's take one that's not going to be a multiple. If I asked you to do 220 degrees, you would do 220 divided by 180 times by pi. So basically put a pi in the top and 180 in the bottom, because pi over 180, they're the same things. That's just 1 over 1, which is 1. So we're really only timesing by 1. Now from there, go old school and do your simplifying fractions. We can score out the zeros. 20 and 18 are both in your 2 times table, so that would become 10 pi over 9. So if you're struggling with the multiples, that is another method to always do. So we've looked at turning degrees into radians. Unfortunately, a lot of the questions we give you in the exams already have numbers in radians, and it's definitely for some people easier to always turn it back to degrees before doing a calculation. So that's what we're going to do in the next bit. We're going to go from radians to degrees. So for these ones, we're going to do the opposite. We're going to times by 180 and we're going to divide by pi. So let's have a wee look. 80 divided by 4. So if I ask you to do 3 pi over 2, again, if you're really, really good at at knowing those core ones, that this isn't too bad. So 3 pi over 2. Do you remember the good old rule, divide by the bottom times by the top? So turn that pi into 180. So it's like me asking you to do 3 times 180 and then divide it by 2. But that's really hard to do mentally. So I would do this bit first. 180 divided by 2 is 90. So you're left with 3 times 90, which is 270 degrees. Now you might not necessarily need to do all that work, and you could do this in your head, but for the sake of this, I'm just showing you the layout. So the next one we're going to do is 5 pi over 4. So we've got 5 times 180 all over 4. Now 180 divided by 4 is 45. So the real sum here is 5 times 45, which is 225 degrees. Next one, 3 times 180 all over 5. So 180 divided by 5 is 72. So we're doing 3 times 72, which is 216. And my last one here is pi over 12. So that's 180 divided by 12. Now, you might be able to do it really easily. If not, let's do your 6 times table. 6 times table gives you 30 over 2, which is 15. You might also know really easily that 12 times 30 makes 360, so you can only get half of 30 if you're only going up to 180. But that's how to do the opposite way, going from radians into degrees. Think of that pi as 180, divide by the bottom times by the top. So if you followed that, okay, a good place to go would be, this is the TJ textbook that I always recommend, that's what we use in class. So TJ textbook, page 49, and try a selection of question 2, 3 and 7. Thanks very much.